name is Caleb, and this is Lab 2 Projectile Motion. The purpose of this lab was to analyze the curved motion of an object tossed into the air. The observed motion will be compared to two computational models, one with and one without the effects of drag force. The object we used was a balled up paper, the observed position was taken through Tracker, and the predicted position was calculated using GrowScript. For the fundamental principles, Newton's second law explains how a system's change in momentum is proportional to the net force applied, and is defined by delta P equals F net over m, or momentum equals net force divided by mass. Drag force is the resistive force that opposes the motion of an object and is directionally proportional to the velocity of the object squared. Gravitational force is the attractive force that pulls objects with mass towards each other. In this lab, the paper ball is being pulled towards the Earth due to the force of gravity with equal but opposite magnitude. The procedures we used were to record a video of a paper ball being tossed into the air in an arc motion in front of a distance holder or a meter stick in our case, import that video into Tracker, and track the paper's position frame by frame, create a computational model of the paper's position using GrowScript, and compare that computational model to the experimental model data. This is a quick video of the paper ball's motion through the air, along with a graph and table displaying its tracked position at each frame. The initial position is as seen, and the change in time from start to finish was 0.667 seconds. This GrowScript code is for the computation that only includes the force of gravity with no drag force. On the left, I inputted all the initial conditions collected through the Tracker analysis. B, which is the constant for drag force, is at 0 as the model is only meant to contain the gravitational force. On the right, I inputted all the forces acting on the system, as well as the velocity and position update formulas to create points in the computational models. In these codes, for the inclusion of drag force, B was increased to 0.001 in order to account for the drag force on the paper ball. That's the only thing that was changed throughout these two different codes. These are the models produced from GrowScript using only gravitational force. As can be seen, the x velocity is unchanged as there is no opposing force in the x direction, and the y velocity is a constant decrease due to the effect of gravity, with the paper's trajectory graphed as well. These models are the ones that include the effect of drag force on the paper ball, which explains the fluctuation in the velocity x graph, the slight curvature in the velocity y graph, and the slightly lower peak in the trajectory graph. This graph relates all three of the models, with the observed model and the drag force model having a more closely related trend, because the original model would have been affected by drag force as well. Some of the possible errors include rounding errors with numbers, which would affect calculations, position tracking, as different placement for the center of mass during the tracking would cause deviations, as well as the angle the meter stick was held at throughout the video. And finally, the ball shape. Since the shape of the ball was not a perfect sphere, air resistance could affect it in different ways throughout the video. For the further questions, neither of the models demonstrate a terminal velocity during the time of the experiment. The F-gravity model shows a linearly increasing velocity, and the model with drag shows an increase in velocity as well. However, with further distance to fall, the net force could eventually equal the force of gravity, which would cause the system to reach a terminal velocity. For the what if question, the object would still take the same amount of time to reach the ground. This is because the only force that is being affected is the horizontal force, which is being reduced to zero. The vertical force and the forces acting upon it would still remain the same.